Section 7.3 deals with confidence intervals for true population proportion. I am going to go over these 4 problems during this integrity video, but before I do so, there's one last problem that I wanted to show you from the Section 7.2 on T-interval problems. If you noticed, it was attached to the lecture notes, and this is the problem. I want to go over this before we start. Proportion intervals. T-interval, it says the following. The superintendent of a golf course is interested in estimating the mean score for professional golfers in his course. He randomly samples the scores of 12 professional golfers from the last tournament, assuming the variables normally distributed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 golfers. And here are the scores of those golfers. First question is, what is the point estimate of the mean score of professional golfers? And I want to show you how I received that by hand and also with the calculator. By hand, you would need to make an X column. If you notice question number 2, what is the sample standard deviation, and round that to 3 decimal places. On notebook paper, I'm going to list these scores vertically: 76, 70, 67, 71, 75, 79, 74, 73, 69, 78, 70, and 74. 76, 70, 67, 71, 75, 79, 74, 73, 69, 78, 70, and 74. Again, this is a problem in which we are given raw data. And this is the superintendent of a golf course is interested in estimating the mean score for professional golfers on his course. And that would be the mean score for all professional golfers in his course or on his course, the entire population. So he randomly samples scores of 12. Sample size is 12. These are the scores below. We have to find the mean and the standard deviation. The word problem does not give population standard deviation. When you read this, you cannot find standard deviation anywhere. Since it is raw data, you will have to find the standard deviation. This would be the X column, and then you need an X squared column. For those of you that do not have a TI-84 calculator, I will remind you that the formula for the mean is the summation of all the data divided by n, and the formula for variance is the summation of the X squared column minus brackets, summation of the X column quantity squared divided by n, all divided by n minus 1. And then to find standard deviation, we would just take the square root of variance. I'm going to square each value, and these will be fairly large values. 76 squared, 5776. 70 squared, just so you can see a couple of these, 4900. So in this column, I'm going to list these. 5776, 4900. 67 squared is 4489. 71 squared is 5041. 75 squared, 5625. 79 squared, 6241. 74 squared, 5476, 73 squared. 5329, 69 squared. 4761, 78 squared. 6084, 70 squared. 4900, 74 squared. 5476. We need to add up the values in the x column and in the x squared column. In the x column, 76 plus 70 plus 67 plus 71 plus 75 plus 79 plus 74 plus 73 plus 69 plus 78 plus 70 plus 74. I received a total of 876. For the summation of the x squared column, when I add all of those values, I received the summation of the x squared column is 64,098. Therefore, the mean by hand is going to be the 876 divided by the 12 golfers, and 876 divided by 12 is exactly 73. The sample mean score of the 12 golfers is a score of 73. X bar is 73. Exactly, no rounding necessary. For the variance, the formula would look like this. 64,098 minus bracket 876 quantity squared divided by 12. All divided by 12 minus 1. And this is variance. The denominator is going to be 11. To see this on the calculator, you would do the 876 and square it, and then you would divide by the 12, and that's the number in the brackets, and you subtract that from the 64,098. So I'm going to do minus second answer, or you could say minus 63,948, and then you divide by 11. The variance is this number. I'm going to write it down. 13.63636364. It looks like exactly 13.63 repeating. The 63 is repeating itself. Then we take the square root of that, and I am going to say second answer so that I use 13.63 exactly. Square root of second answer equals 3.6927444729. And this is when you look at your raw data values and they are whole numbers. So according to Chapter 3, we will round to the nearest tenth, an additional decimal place. And then take the square root of 13.63 repeating. 3.6927444729 is about a 3.7. In the handout, notice that the lecture notes say to round to 3 places. This means that I am not going by the rounding rule in Chapter 3. The understood rounding rule in Chapter 3 is to look at your raw data and go to an additional decimal place. So technically I should have rounded to 3.7. So I'm going to work this same problem, but I'm going to use 3.7 instead of the 3.693 here in the lecture notes. The next question for this same problem says, construct the 98% confidence interval for the true mean score for all professional golfers on this course. And I discussed why this is a T interval. Sigma is unknown. It was raw data, and we found our sample standard deviation to the nearest tenth, which was 3.7, to 3 places, 3.693. Raw data. They did not tell population standard deviation. We had to find from the raw data the sample standard deviation. And N is only 12 golfers, 12 scores, so N is less than 30. Both conditions are satisfied, so this is a T interval for the true mean score of all golfers. A T interval. A 98% T interval for the mean, and it's a raw data problem. The formula is x bar minus t times s over the square root of n, and x bar plus t times s over the square root of n. And I'm going to write this down. Again, with this, in the lecture notes, I used a standard deviation of 3.693. I'm going to show you 3.7, the actual rounding rule from Chapter 3. The next question says, find the 98% confidence interval for the true mean score of all golfers. Again, it's a T interval. Sigma is unknown because S is about a 3.7. And at the same time, N is less than 30. N is only 12. Both conditions are satisfied. The formula, x bar minus t sub c s over the square root of n less than mu, x bar plus t sub c s over the square root of n. Going to the t table, we can find our t sub c in this problem. 98 degrees of freedom, or 98% degree of confidence, forgive me, 98% degree of confidence, and our sample size is 12. According to the t-table, we have to go to row 11, which is degrees of freedom, sample size minus 1. So 12 golfers, go to row 11, not row 12, and then column 98%. That's our degree of confidence. Your two fingers meet at 2.718. Don't go to row 12, go to row 11, and column 98%. The T sub C critical value is 2.718. 2.718. Row 11, not row 12. I'll put this into the formula. This is going to be 73 plus 2.718. 3.7 divided by the square root of 12. 73 plus 2.718. 3.7 divided by the square root of 12. The next thing I'll ask, and this is supposed to be a minus, sorry about that, subtract and then add. I will subtract E and then I will add E. The margin of error is the maximum difference allowed between the point estimate or the sample mean x bar and the true population mean mu. The maximum difference allowed. That is going to be the 2.718 times the 3.7 divided by the square root of 12. 2.9031. 2.9031. Again, if you're following the hard copy of the lecture notes, with the hard copy, I say let the standard deviation of the sample go to 3 places, which is 3.693. So that's why we have a slightly different E. I use the standard deviation of 3.7, rounding to the nearest tenth, as we're told in Chapter 3. 2.9031, 2.9031, rounded accurately to 4 places. Subtract from 73, and you have 70.0969. Add to the 73, and you have 75.9031. We round finally to the same number of places as the given sample mean X bar. So that's a whole number. 70 is the lower, and 76 is the upper. We are 98% confident that the true mean score of all golfers is between 70 and 76. I will ask you separately on the test for the critical value from the T-table. I will ask you for E, and this is the E that we received by using the sample standard deviation of 3.7. And I will ask you for confidence interval width. That is a difference of 6. 76 minus 70 is 6. So all of those questions I can ask you as well. The calculator. With the calculator, you would go to Stat and Test, and down to number 8, T interval. Stat, Test, number 8, T interval for the mean. Enter. This was a raw data problem, but I'm going to treat it as a statistical problem, and I'm going to put in my mean of 73, my sample standard deviation of 3.7, the sample size of 12, the C level of 98%, and calculate. Even though it was a raw data problem, I'm going to put in the sample mean that I found by hand, the sample standard deviation I found by hand, I rounded to the nearest tenth, the sample size, the confidence level, and calculate. If you're following the lecture notes, like I say, give the standard deviation of 3 places, then you're putting in 3.693 here. But actually, we're going to follow the rounding rules for Chapter 3, and I'm going to put in 3.7 and then calculate. 70.097 to 75.903. If you round accurately, it's 70 to 76, which is the same answer we received by hand. A few moments ago, I could have went to Stat and Edit, and I'll just use the L2 column to put in my values. The 12 scores: 76, 70, 67, 71, 75, 79, 74, 73, 69, 78, 70, and 74. Hopefully I did not make a mistake. Then you go to Stat, arrow over to Calculate, one variable statistics, and I put mine in L2 this time. Frequency is blank, and then Calculate. The mean is 73, and the sample standard deviation is 3.693 if you round to 3 places, but 3.7 if you round to 1 decimal place. You can find the information this way, and then go to Stat and Test, and go down to number 8, T interval. Arrow over to Raw Data and press Enter. I put my data in the L2 column. Frequency remains 1. The C level's 0.98, and calculate. Let's see what the difference would be if we calculated it as raw data, since we did take the time to put the raw data in the calculator. to 76. Once again, so the same answer by hand. 70 to 76. And remember the trick for E. 75.8976 minus the 70.1024. And just so you'll know, I'm receiving those numbers from, let me do this. The trick for E, there's several different ways. Let me go back to stat, test, number 8 as a T interval. I forget that I'm going to treat it as raw data. And these are the answers I just received when I treat it as raw data. I keep forgetting I have to write these numbers down. 75.897 minus 70.103. Some versions of the calculator, when you start typing in, this doesn't disappear. But this new version, if I start typing in here, then all of this information disappears. So try to remember to write those down. Here's the trick. The confidence interval width without rounding divided by 2. 2.897, which when we used a standard deviation of 3.7, our E was 2.9031 a few moments ago. And that's with a standard deviation of 3.7. In other words, that was 2.718 times 3.7 divided by the square root of 12. And I got 2.9031. But if you use your calculator trick, confidence interval width divided by 2, you get 2.897. Again, the way that I do the problem is I do the problem for the test the way the textbook says to round. Even though in the lecture notes I said go to 3 places, technically we should have kept it as 3.7, not 3.693, the standard deviation. So my final answer, I'm looking from 70 to 76. If you follow the rounding rules, then this is what you have for E, 2.9031, and the confidence interval width is 6. So all in all, for this problem, this is what I would be looking for on a test. And that's with correct rounding throughout, using the formula by hand, the T-table, and rounding the standard deviation to the nearest tenth, 3.7. I wanted to show you the raw data problem for the T interval before I started the proportion problem, so I'd like to do that now. These are the 4 problems that deal with section 7.3 proportion problems, confidence intervals for true population proportion. And I am going to work these problems now. The preliminary notes are very important though. Confidence interval for true population proportion, P, it's actually rho. Thank goodness there are no conditions to be met. If it says to calculate a proportion interval, then you calculate a proportion interval. The formula is P hat minus Z sub C times the square root of P hat times Q hat over N. P hat plus Z sub C square root of P hat Q hat times Q hat over N. The Z is found from the 2-page Z table, and it's based upon the degree of confidence. So if it's a 90% confidence interval, then Z is 1.65. If it's a 95% proportion Z interval, it's 1.96. And I have those written here. So these same ones that we've memorized for the Z interval for the mean problems will also be the same critical values for the proportion interval problems. Even though it's a confidence interval for proportion, is still a type of Z interval in which you use the 2-page Z table. So that is good news. And the procedure that you use to find these Z's is the same procedure as in video number 1 or lecture number 1 from section 7.1. Again, I can ask you for a 94% proportion interval, a 96% proportion interval, a 97% proportion interval, an 80%. Something that you've not memorized. So the procedure is very, very important to know how to find these z's. The thing that you don't realize at this moment how to do in the formula is the p-hat and the q-hat. The p-hat is called sample proportion, and it's found from reading the problem. P-hat is the best point estimate for P. P-hat, sample proportion, is the best point estimate for population proportion. Here is an example. It's very easy to find. Find p-hat if in a sample of 30 college students, 15 students will stay on campus during spring break or fall break. P-hat is x over n, or 15 out of 30, or 1/2, 50%. Very easy. So 15 out of 30, or 50% of students, will stay on campus during the fall or the spring break. Very easy value to find. Now, p-hat and q-hat are related by the fact that they have to add up to equal 1. They do not give you q-hat in these problems. They only give p-hat. So if p-hat is 0.5, then q-hat has to be 0.5. The rest of these problems are the 4 problems that you see there, but I'm going to work these problems by hand all the way through here. Problem number 4. And show you how to come up with these answers. The only other background information that I need to remind you of is the sample size formula. And the sample size formula looks like this. P-hat times Q-hat, Z over E quantity squared. Always round to the nearest whole number regardless of decimal. Always round up. But this is sample size needed for proportion. It is not the sample size needed for the mean, but this is the sample size for proportion. And I want to go over these values. The textbook says if p-hat and q-hat are not given from a previous study or a recent study or a past study, by default, let p-hat be 0.5 and q-hat be 0.5. This is going to be very, very important with those problems dealing with the sample size formula that I just spoke about. With these sample size questions, p-hat and q-hat are given from a past study, a previous study, a recent study. And if they don't give you p-hat and q-hat from a past study, a recent study, previous study, let both of these be 0.5. And it's the textbook that says that, not me. Let's take a look at the 4 problems, and I'll work every single one of those out for you now and show the calculator. Problem number 1. Also the rounding rule. 1 proportion Z intervals. Your final answers with these proportion intervals. The true population proportion P. Round accurately the lower number and the upper number to 3 decimal places. So this is the rounding rule number 6 for this section 7.3 on proportion. Here we go. In a study of 100 people, 85 said they were happy with their present home. Find the 90% confidence interval for the true population proportion of people who are happy with their present home. And I will remove this. But in a study of 100, that's your N. 85 are happy, that's your X. 85 out of 100 will give you your p-hat, sample proportion. Find the 90% confidence interval for true population proportion. It does not say true population mean. Therefore, I'm going to write this down. N is 100. X is 85. And they ask us to find the 90% confidence interval for the true population proportion P. And that's basically all they give us. From this, we can find P hat. P hat is x over n, which is 85 out of 100, which is 0.85. Therefore, Q hat is 1 minus P hat, or 1 minus 85% is 15%. They must add up to equal 1. Formula: P hat minus Z sub C, square root of P hat times Q hat divided by n, is less than P hat plus Z sub C, square root of P hat times Q hat divided by n. Since it is a 90% proportion Z interval, Z is 1.65. Let's plug in. 0.85 minus 1.65 square root. Under the radical, put 0.85 times 0.15, all divided by 100. 0.85 plus 1.65, square root of 0.85 times 0.15, all divided by 100. Let me show you how to find E, the margin of error. This time, E, the margin of error, the number you subtract, the number you add, is the maximum difference allowed between the point estimate, P hat, which is sample proportion, and the true population proportion, P. P hat is used to estimate P, and the margin of error is the maximum difference allowed between the two. So, this is how I do it. I'll show you two ways. Under the radical, I say 0.85 times 0.15. Enter. Divide by 100. Enter. I take the square root of that, and instead of retyping that, I say second answer. Under second answer is 0.001275. Enter. The last thing I do is multiply by 1.65. Therefore, your E is 0.0589. There's your margin of error. Instead of working from under the radical to the outside of the problem, you can plug it in directly if you're careful. Here we go. 1.65 times the square root. You need a lot of parentheses. 0.85 times 0.15, close parentheses, divided by 100. You can see all of that's under the radical. 0.0589. Regardless of how you do it, and you just have to practice, you get 0.85 minus 0.0589 less than P less than 0.85 plus 0.0589. And this is where you'll subtract from and add to, and the final answer is given to 3 places accurately. That's 0.7911. And this is 0.9089. The textbook says with these proportion intervals round to 3 places accurately, 0.791 and 0.909. You can give it as a decimal rounded to 3 places accurately, but you could also give it as 79.1% less than P, less than 90.9%. Therefore, we are 90% confident that the true population proportion of people who are satisfied with their homes will be somewhere between 79.1% and 90.9% for this problem. Now I would like to show you how to utilize the calculator. Again, keep in mind, for this problem I can ask you for E by itself, I can ask you for the critical value by itself, I can ask you for the final answer, I can ask you for the confidence interval width, and that's 0.909 minus 0.791 as a decimal. And that difference is 0.118, or 11.8%. There's your confidence interval width. So I can ask for all the little parts. Now, you go to Stat, arrow over to Test, and it is, keep on going down, it's letter A. And it looks like 1 prop Z int, but it's 1 proportion Z interval. Stat test alpha A. Stat test alpha A. Enter. The X was 85 people out of 100 are happy, and the C level was 90%. With these proportion intervals, there's not a lot of information you have to put in the calculator. So 85 out of 100 were happy with a C level of 90%. 0.791 to 0.909 would be your final answer for that. Again, that's the same as by hand. So stat and test and all the way down to alpha A. 1 prop Z interval. I love these. These are actually my favorite of the entire chapter, the proportion problems. I would like to show you problem number 2. A poll of 1,015 adults found that 13% approved of Congress's work in 1995. Find the 95% confidence interval for the true proportion of adults who feel this way. True proportion. A poll of 1,015, that's your sample size, found that 13% of the 1,015 approved of Congress's work in 1995. Find the 95% confidence interval for the true proportion of people who feel this way. With this particular problem, I am going to write down what they give you by hand. And this is problem number 2. In a poll of 1,015, 13% of those people approved. This is rare, but that is your p-hat. Sometimes they give p-hat directly. Sometimes they give it indirectly. In problem number 1, they gave it indirectly. In a study of 100 people, 85 said they were happy with their home. But here, in a poll of 1,015, 13% of those people out of the sample approved of Congress. And they want us to find the 95% confidence interval for true proportion. And that's P. Since p-hat is 13% or 0.13, q-hat is going to be 1 minus p-hat, which is 1 minus the 13%, which I believe is 87%. .87. And the critical value is 1.96 because it's a 95% Z interval. Here we go. P-hat minus Z sub C, square root of p-hat times q-hat divided by n. P-hat plus Z sub C, square root of p-hat times q-hat divided by n. And it looks like this. 0.13 minus 1.96 square root of 0.13 times 0.87 divided by 1,015 less than P less than 0.13 plus 1.96 square root of 0.13 times 0.87 divided by 1,015. In the calculator, I still like it this way. 0.87 times 0.13 divided by 1,015, and I take the square root of second answer, and then the last thing I multiply by is the critical value. So I work my way from under the radical to the outside of the radical, 0.0207 to 4 places. You can also plug it in directly, 1.96 times the square root of parentheses 0.13 times 0.87 divided by 1,015. Maybe that's easier. 0.0207 and I'll remove this. 0.13 minus 0.0207, that's your E. 0.13 plus 0.0207. Add to the subtract from the 0.13, 0.1093, and add to it 0.13 plus 0.0207, 0.1507. Round each to 3 places, 0.109, 0.151. And you can also say 10.9% to 15.1%. Calculator. With the calculator, if you notice, they give p hat is 13%, but p hat is x divided by n. And n is the 1015. So we know that x over 1015 is equal to the 13%, or you could just write this down. If the word problem doesn't give you x, but your calculator calls for x, take your p hat that they give you and multiply by n. So 13% of the 1015, which is 0.13 times 1015, will give you n. 0.13 times 1015. 131.95, but you'll have to put it in the calculator as a 132 for your x. This is only TI-84 calculator, people. Will you have to worry about this? If they give you p hat directly, like the 13%, and they don't give you x, x is p hat times n, and you have to put it in as a whole number, rounded accurately. So stat and test, and it's alpha A. 1 prop Z interval. Enter. 132. 1015.95. If you put the x in as 131.95, it'll kick you out and say there's an error. So you have to put it in as 132. 0.109 to 0.151, which is the same as what we got with the formula by hand. Question number 3, and then I'll leave question number 4 for you to read in the lecture notes on your own for the sake of time. This is a sample size question. A researcher wishes to be 95% confident that her estimate of true proportion of people who travel overseas is within 0.04 of the true proportion. Find the sample size n if in a study prior to this study it showed that out of a sample of 200 people, 80 traveled overseas. A lot going on, so let me show you. A researcher wishes to be 95% confident, that's important, that her estimate of true proportion, that's important, it does not say true mean. Estimate of true proportion, by the way, her estimate of true proportion would be p hat. Her estimate of true proportion of people who travel overseas is within 0.04. This person is saying that her estimate, her margin of error, is 4%. The key word within. So she wishes to be 95% confident that her estimate of true proportion P, and that would be the maximum difference between P hat and P, which is the margin of error. The margin of error is only 0.04. Find the sample size n if in a past study, a previous study, a recent study, it showed that out of a sample of 200 people, 80 traveled overseas. So information-wise, what is given in this problem is the researcher wants to be 95% confident, so that's our degree of confidence, that the estimate of true proportion of people who travel overseas is within 4%. So the maximum difference between P hat and P is 4%. Find the sample size, question mark, if in a prior study to this, not this same study, but in a prior study, out of 200 people, 80 traveled overseas. And from this prior study, it's giving us a way to find p hat. X over n is 80 out of 200. This is important from a prior study. Remember, if they don't give you p hat and q hat from a prior, past, recent study, default, let it be 0.5. 80 divided by 200 is 0.4. So p hat is 40%, therefore q hat is 60%. They have to add up to be 1. P hat plus q hat must equal 1. Sample size formula. N is equal to p hat times q hat times z over e quantity squared. And this is the sample size formula for proportion. Remember, this p hat and q hat is from a past or recent or previous study. So I'm going to put in p hat is 0.4 from the prior study. 80 out of 200 travel overseas. Q hat is 0.6. Since it is 95% confident, that implies that z is 1.96 because it is a type of z interval using the z table. And within 4%, e is 0.04. Plug it into the calculator and always round up regardless of decimal. 0.4 times 0.6 times 1.96 divided by 0.04 quantity squared equals 576.24. So 0.4 times 0.6 times 1.96 divided by 0.04 quantity squared. And I'll write that down. 576.24. Always round up, everybody, so it's 577. On the multiple choice test, I plan to put 576 and 577 and something like a 575 and a 578. Make sure you go with B. I'm testing your ability to know this rounding rule. And remember, when it's a sample size question, rule number 5, always round up regardless of decimal to the nearest whole number. So that's rule number 5, and that would still be 577. Question number 4, I'll let you do on your own, but question number 4 is a very good problem. This is a little bit different than any of these problems. In a sample of 600, a researcher wishes to have a maximum error of estimate of 4%. So that's your E. On the specific proportion who favor gun control. This is different. Find the degree of confidence or confidence level if in a recent study, past study, p hat is 50% who were in favor of gun control. I'll give you a hint. If you can find your Z-score for this problem, then you will be able to know your degree of confidence. So do work on that problem. That's a different problem from the 3 above. I hope this lecture has helped you, and if you need any help with any of these questions, please let me know. The last lecture is from 7-4 on confidence intervals for true population variance and standard deviation. And I have to teach you how to use the chi-square table and the new properties of the chi-square distribution. But for these proportion intervals, it was that same old z distribution, the standard normal distribution using that 2-page z table. So we already know about that z distribution. But chi-square is a different story, so stay tuned. God bless you and have a wonderful day.